Optimizing the MySQL Server Environment, Part 2 of 2. As you know, the first part of this two-part mini-series dealt with the first two elements of server subsystems, in particular, the memory and hard disk environment. Here in the second part, we'll look at the third and fourth elements, that is to say, the network and operating system subsystems. Let's get to work. Network considerations. Although we talked about networking and operating system optimization in general terms in the previous nugget, here we're going to talk about them in a little bit more greater detail to cover our exam objectives for the DBA2 test. Remember that MySQL as a client-server application is fully reliant upon your network connectivity. As previously discussed, the faster you can open up your network bandwidth, the more efficiently your MySQL server can process queries. Therefore, if you can move, for instance, from a 100 megabit connection to, say, a gigabit connection, and if you can move, for instance, from copper cabling to fiber cabling, so much the better. Obviously, this requires money to do, it takes resources to do, and architectural changes to your network to undertake. However, this is a suggestion, and put it in your conceptual pipe and smoke and get ready to answer questions on this for your exam at the very least. Another point that I can't stress enough is to consider users' physical distance from your server. In other words, how many connectivity devices exist between the user's desktop, where the user interacts with MySQL server using their line of business client or the MySQL client, and the MySQL server machine itself. Now, these connectivity devices would include, for instance, the network interface card in the user's computer, the cabling media itself. We have to make sure that there aren't any shorts, any opens. We have to consider environmental issues like crosstalk, attenuation, interference, and so on in terms of where the cable run is going. Of course, we have intermediary devices such as switches, how those switches are configured, what your access layer of your network is doing in terms of how you have that opened, duplexing options, etc. How fast this connectivity layer is it 100 megabit? Are you fortunate to be running 1000 megabit or gigabit to the desktop? And in your switch level infrastructure, are you at 100 or a gigabit there? And then finally, from the switch, the core switches, and then ultimately to the server machine, are you running fiber, gigabit, etc.? Now, the farther away your users are to your server, it stands to reason the more contention there's going to be for resources, because you just have a wider pool of users competing at the switches for network access, much less access to the server itself. The point is, eventually, your user populations wind up getting so far away from the server. Let's say you've got your MySQL server over here, and you have a user population that's fairly far away physically from where the server is. It might make sense to bring up another physical server more physically close to the users and set up a replication architecture. Now, replication as such is beyond the scope of our objectives at this point. Just know that that's certainly possible, where we would bring up another MySQL server over here and then create a duplicate instance, a duplicate copy of the database, and replicate or synchronize changes from the one to the other. That would solve this problem of physical distance between the servers and the users. Finally, we have the suggestion to kind of put a closer eye or a closer analytical watch on our network bandwidth and our network performance. I've stated this before at the outset of our discussion on network optimization and performance tuning, that we want to move away from that notion of touchy-feely or intuitive thought of network performance and get into more of a metric mindset in terms of putting numbers and charts and graphs and real data behind how our system's performing. It's one thing to deal with user complaints saying, hey, the network feels slow, or just your own thought that the network is performing poorly or could be running better. And it's a different thing entirely to actually see data and see charts and graphs and to see characterizations of different protocols on your network and see that in a graphical way. So therefore, the suggestion is to consider the use of network monitoring tools to be able to visualize that data. Now, a general principle of IT certification exams, this certainly holds true for MySQL, is that all else being equal, we're limiting ourselves to first-party tools. There are certainly plenty of third-party network monitoring tools in the open source and in the enterprise space that are great and wonderful, no question about it. However, we need only concern ourselves with those that are available directly from MySQL. Furthermore, I'm going a little bit off the reservation here. This particular subject, you do need to know that the use of network monitoring tools is a suggestion for characterizing network traffic and tuning performance of MySQL, but you do not need to know specific products for your exam objectives. To give you a little bit of extra value in the course right now, I'm taking us to the mysql.com/products page, and I just want to briefly show you these. You probably know that MySQL Server has two versions, one called MySQL Community Server, and this is the quote-unquote free version of the product that's licensed under the GPL license, the open source license, the quote-unquote free software license. The other way to obtain MySQL is to purchase the MySQL Enterprise Server. And when you pay for MySQL, you're essentially buying a whole bunch of top-tier support. Not only are you buying the top-tier support, but you're getting regular scheduled updates directly from the MySQL team. You're basically buying a Lamborghini edition of the MySQL Server software. Now, you'll notice on this page that in addition to the Enterprise Server, there are a couple add-ons that you get with the Enterprise subscription. One of them is called MySQL Enterprise Monitor. And what Enterprise Monitor is, let me come over here. There's actually two tools. One is MySQL Enterprise Monitor. Another is MySQL Query Analyzer. These are web applications. I'm showing you a picture of the dashboard here that make it really, really easy to get a picture of not just your network performance on your MySQL servers, but your query performance, your disk performance, your replication performance, your event status. For many DBAs, something like this is worth the price in itself of purchasing the enterprise license for MySQL Server. This enterprise dashboard that you're seeing here right now, it's probably difficult to see, but I'm looking at charts and graphs that are showing CPU utilization, memory usage, row accesses, opened tables, and believe me, in here there's lots of network bandwidth metrics as well. And you can see this data not only for a single MySQL server, but these products can also be used to monitor all of your MySQL instances. It's called MySQL Enterprise Monitor. I just wanted to show you that in case you weren't aware of it. And by the way, just full disclosure, I'm not getting any financial incentive or kickback from Sun Microsystems, from Oracle, from the MySQL community. I'm simply speaking as an IT pro and as a CBT Nuggets trainer here. That's all. Next, I'd like to share with you 3 really nifty network performance tips for MySQL Server that I found from forge.mysql.com. This is a really excellent website that you should be aware of. The first of these tips is minimize traffic by fetching only the data that you need. And all 3 of these subpoints basically are ways to do that. 1, paging chunked data retrieval to limit your rows. 2, don't use select splat. 3, be wary of lots of small quick queries if a longer query can be more efficient. Right, so basically you just want to write your select statements as accurately as possible. We've already talked about point 2 quite a bit. Select star, as you know, is going to retrieve all columns and all rows, unless you're using, say, where to filter certain rows back. But certainly select star is going to retrieve all columns. You don't want to do that. So bottom line, to summarize that, fetch only those rows and columns that you need and only send the number of selects that you need. write a single longer query rather than a bunch of smaller queries. Again, with network performance, we have to think in terms of how many queries we're sending over the pipe, not so much how long each query is. And that actually is what points 2 and 3 speak to. Point 2 says use multi-query if appropriate to reduce round trips. Now, what does that mean? That probably doesn't make much sense to you if you're not familiar with web programming. Multi-query is a method or an action that's usable in the PHP web development language. And multi-query is especially useful in PHP because it can be used to perform multiple queries end-to-end on a MySQL database. Therefore, if you're running or creating a PHP web application that relies upon a MySQL database backend, multi-query can be really nice in terms of minimizing network performance because, again, instead of sending queries one after the other after the other after the other serially, which can ultimately clog a network connection, and these are called round trips because they're separate opens and closes. You're opening a connection, closing it. Opening a connection to MySQL, closing it. Opening it, closing it. Those are separate kind of recursive round trips to and from the server. When you open a multi-query method, you're making a single pipeline to MySQL and then keeping that tunnel open while you execute multiple queries, you see? Again, that's enhancing network performance. Finally, point 3 here says use stored procedures to avoid bandwidth wastage. Again, it's kind of the same principle of multi-query. Instead of issuing multiple recurring round trips to the server, we have a single statement. A call statement, you'll recall, is what we use to call a stored procedure. The client issues that single call statement, sends that to the server. The server then invokes the stored procedure and runs the code at the server. And all that went over the wire from the user's machine to the server is a single line of code. Whereas otherwise, you might have, if that stored procedure contained 100 queries, otherwise that client would have sent 100 separate statements over the wire. In summary, all 3 of these tips are largely saying essentially the same thing. Do what you can to minimize the number of statements that are going over that network connection. Whether that connection be wired or wireless, it doesn't matter. We're going to complete this nugget with a consideration of optimizing the host operating system. It's a little bit different. We're not actually going to be looking at tweaking Windows specifically or tweaking Linux or Mac OS X specifically. Instead, we're going to look at some system variables that touch on the host operating system, but certainly pertain in practice to MySQL. The first of those is a system variable called OpenFilesLimit. And what this does, I'm taking this syntax information directly from the MySQL reference manual, is it changes the number of file descriptors available to the MySQL daemon, and I've helpfully given you over here a description of a file descriptor, and basically that's an open file. And essentially, when MySQL opens a table for a user, it requires an open file. So there's a direct proportional relationship to an open table and an open file. And so you may wind up with, depending upon how another system variable is set, MySQL refusing user connections, and you may have to jog up the open file limit on your server. So actually, I might as well give you that other system variable so you have it. It's called table_cache. And this is a global variable. It's numeric. The default is actually 64, and you can crank it up to over 500,000. And this table cache is the number of open tables for all threads, so all connections server-wide. And as we've previously discussed in the previous nugget and elsewhere in this course, table cache is related to memory, and this is going to allow MySQL to cache recently opened tables for faster access. Now, depending upon the storage engine, for instance, MyISAM requires 2 file descriptors for each opened table. So if you had, for instance, 64 tables, 64 MyISOM tables in cache, that would require at least 128 open files. So like I said, there is a direct proportional relationship between how big your table cache is and how many open files you're going to have to allocate. Now, of course, there's the question, how do you get a handle on about how many tables you're going to want in your cache? Well, remember show status from earlier in the course? There are a couple status variables you want to look at. There's a status variable called opened_tables. If you look at that over time, that should give you a pretty good idea about how many tables your MySQL server has open at any given point in time. And that should give you a good idea on what to set table cache, which should in turn give you a pretty good idea on how you can size open files limit. The next operating system related parameter we'll look at, we've discussed this before, this is max connections, another globally scoped dynamic variable. It's numeric in type, and the default value is going to be different depending upon your version of MySQL. Below version 5.1.14, the default maximum connections was 100. This was boosted to 151 as of MySQL Server 5.1.15. And that's all it is, the number of simultaneous client connections allowed. And as previously discussed, I'll repeat it again now, you would want to size this appropriately for your system. You don't want it set too high to avoid overburdening your system, especially if you have other services besides MySQL running on that box. So you don't want it set too low, and you don't want max connections set too high. Finally, we have the backlog system variable, another globally scoped variable that's numeric in type. The default is 50 and can be set up to 65,535. Very simply, this guy is defined as the number of outstanding connection requests that your MySQL server can have. And essentially, if your MySQL server becomes overloaded and cannot service the current connection queue, connections start to back up. And it tells us at the end of this text from the MySQL reference manual, you need to increase this number only if you expect a large number of connections in a short period of time. Now, there's two ways to address this. Either you can adjust this value and kind of hedge your bets, or you can simply kind of head this off in the pass and take a look at why might I be experiencing backlogs or outstanding connection requests. What changes can I make at the operating system level in terms of my software? Or more pointedly, what can I do at the hardware level, in particular in this nugget, at the network level, to make those connection requests, make that queue disappear? Optimizing the MySQL server environment, part 2 of 2 review. In this nugget, we completed our consideration of those 4 server subsystems and how to optimize them for a MySQL server environment. We looked at optimizing the network subsystem and the operating system subsystem. I hope that this has been informative for you, and I'd like to thank you for viewing.